journal editors, but also very, very popular with research councils. So in the UK, we have a couple of very large research councils, the EPSRC and the ESRC, and they both maintain a whole volume of databases, and they love it if people use their databases. They're maintaining these databases to be used. So it's a very, very big tick in the box if you're applying for research council funding, if you can use the databases which they provide. Obviously, other researchers use databases. So we had a researcher called Natini, who's moved on to Oxford Brookes, I think, and we had Konstantinos, who I'm very glad is on this call, and he's obviously used databases very successfully in his research. And panel data, I know I've seen the research in the UK are very interested in people using panel data. That's about the sum total of my knowledge of panel data. So I'm very looking forward to finding out much more about it. But it's a hot topic. We're very lucky to have a speaker to be able to talk to us about it. So I hope for the next about 45 minutes, you're going to enjoy this introduction to this topic. So I'm going to introduce Yuti and say thank you very much for coming, Yuti, and we look forward to your presentation, and over to you. And I'm going to switch my camera off.
Okay. Thank you so much, Nigel, for the introduction. And yes, you very rightly said that panel data is a hot topic. And now we, particularly in finance, what I've observed, we've moved from panel to dynamic panel data rather. So it's here to stay, and we should make the best out of it. So thank you so much for giving me an opportunity to actually have a discussion on very little knowledge that I have to share with you. Right. So I'll begin with this. So we're going to talk about panel data and what is it? What is the nature of panel data? Where we can apply it, and how can we actually apply it? So I'm going to discuss certain techniques also, and based on the nature of the data, how and when you can apply it. And then we'll transition to dynamic panel data. This is going to be the flow of the presentation for today. So talking about data, first of all, as we all know, it's just a set of values, right, which represent measurements or observations. But when we talk about researchers like you and me, right, so and when we talk about econometric analysis that we conduct, there are three major types of data that we deal with, right? So one is the cross-section data, the other is time series, and last, which we are going to discuss in detail, is panel data, also sometimes referred to as longitudinal data. So let's first understand the first two types of data so that we are able to understand the usefulness of panel data over these two previous types. So cross-sectional data is basically, when you collect data of several individual units, but the time period has to be single, just one time period, right? So it is characterized by, say, for example, you're collecting data for firms, economies, or individuals, maybe cities, right? But however, the data is collected for just one time period. Right? Say, for example, you want to know how much is the expenditure on food for this particular city in 2023, right? So that kind of data is called as a cross-sectional data. Moving ahead with the next type that we have. So this is just an example of, so if you look at the first table that we have, is wherein I have certain economies, India, China, USA, UK, and one variable, the data that I'm collecting is, say, unemployment rates of these countries. So this kind of data is a cross-sectional data because this is going to be just 1 year and this data is collected. Moving ahead, time series data is just the opposite of what we call as the cross-sectional, because here we collect the data on the basis of multiple time periods. However, we are focusing only on a single unit, right? So a very popular example, if we see for time series data, is stock price data. Right? So for example, if I want to check, how a particular stock, say Walmart or, Microsoft, how is it performing over, say, past 10 to 15 years, or say past 12 months, right? So likewise, here I have one unit, which is Microsoft, and I have data on the basis of multiple time periods. Similarly, if you leave finance, maybe in marketing, you can use this data wherein you want to see how are the sales of a particular product going, right, over a period of time. So this kind of data is known as a time series data. The frequency can be either daily, weekly, hourly, monthly, quarterly, or annually, dependent on the requirement of the question that you're investigating. Moving ahead, there's one very important point of difference between cross-section and time series. So if you look at cross-section data here, right, if I place India on the third row and USA on the first row, it hardly will make any difference in the outcomes, right? However, when I talk about time series data, say for example, if you want to check the sales trend of Walmart, the January, February, March, April months, the time periods are very important and they should be as it is. If you change the the order of this kind of a data, the interpretation actually doesn't make any sense then, right? So this is one difference, that time series has to be chronologically arranged for deriving meaningful outcomes out of that data. So now we've just discussed the basic cross-section and time series. Taking it ahead now to what we really want to discuss today is panel data, right? Now panel data is nothing but a combination of these two types of data, right? That is cross-sectional and time series. So cross-sectional, multiple units, one time period. Time series is opposite, multiple time periods, one unit. When you combine both the two, you get multiple units, cross-section units, as well as multiple points in time. So that kind of data is basically known as panel data, right? Okay, so now that is easily understandable that, okay, you mix both of them, you have multiple cross-section units and multiple time periods in the data. That's panel data. But why is there a need to move from cross-section or time series to panel data altogether? So we need to know why is it important, right? So first and foremost, as you all know, for researchers, data is something which is of very high, it's a very high value when it comes about, when it comes to research, right? So for example, if there's a saying I must highlight here by William Edward, who says that in God we trust, others bring data, right? So the more the data, the better it is for inferences, for interpretations, right? So the moment you deal with panel data, you've added more data points, more information into your in the entire gamut, right? So therefore, it provides you an option of having high variability in the data, which leads to better outcomes, in the sense that the outcomes now are going to be more efficient, right? Now, I don't know how many of you are aware of efficiency of estimators. So I have one formula here written. So just not getting into detail, just to explain how more information will lead to more efficiency, we say efficiency is when the errors are minimum, right? The efficient outcomes are when you have least errors. And errors we define by variance. So the formula of variance is written. The more is the number of additional information. So basically what will happen is this n is going to be higher, and because of which this s square, the variance, is going to be lower due to this inverse relationship. And that's how I mean to say that because of additional information, we tend to get less error, or you can say more efficient outcomes. Apart from just this benefit, there are other benefits of using panel data also. So one of them is, generally when you're dealing with quantitative data, there are certain variables which are not measurable, or you can say unobservable. Like say, for example, when you're checking, the firm performance, of a firm, there are certain variables like managerial, the manager's personality, his leadership style, his ability, that you're not able to observe in quantitative terms. So for that case, I say that when you have panel data, yes, the panel data does take these things into account. It controls for it, how we will see in the future slides. Okay. Another thing that is another benefit of using panel data is that now we are actually looking into the dynamics of change, because the moment you take multiple time periods into account, right, you are actually looking at how that particular variable is changing for one cross-section unit across time also, right? So this gives me actually learning or looking at the dynamics of change. across all the cross-section units. Another most important thing from researchers' point of view is I'm able to use a larger data set. Okay, moving ahead, we need to know what are the types of panel data is available, right? So whenever you're dealing with data, you should be aware of certain types of data that are there. So one classification that we have is balanced and unbalanced panels, right? For this, I'll take you to another slide. Okay, so can all of you see this table here on the slide? Okay, so am I fast? Am I slow? Everything's going fine? If some of you could just say yes or no.
Yeah, I think
Yes.
you're going fine. Yeah.
Okay, great. So what I want to show here is, now I have told you there are two types of panels. One is a balanced panel, the other is an unbalanced panel, right? So how do we identify whether the panel that you're dealing with is a balanced or an unbalanced, and what is actually meant by the two? So if you look at it, what is this? It's basically a data for 10 patients. So for example, if I am if I am a dietitian and I have 10 patients who come up to me for losing their weight, right? So now I want to see over the period of last 3 months, how have they performed, in the sense, what is the scenario of their weights? Has it come down? I want to have that analysis. So for that, I tell them that every month, the last day of every month, you note down your weight in kgs, right? So if you look at patient A to B to C till J, all of the patients have noted down on the last day of the month for last 3 months, January, February, and March, their weights. Now, this kind of data, if you look at, is a balanced data. Now, how can I say it? If you count these observations, how many observations are these? 30 observation, right? So 3 months data for 10 patients, that means n cross t, that means 3 into 10, which comes out to be 30 observation. So this kind of a data is known as a balanced panel, wherein you have equal number of observations for each. So all the patients have 3 observations in front of them, right? So this kind of a data is a balanced panel. Talking about unbalanced panel, so sometimes, now it might happen that some of my patients forgot to actually measure their weights on the last date. So say, for example, patient number A did not actually note down his or her weight in February. Similar was the case with the patient D, F, H, and J. All of these forgot. So what do we have here? We have missing observations. So whenever in a panel you have a missing observation, you have few missing observations. Now what will happen if I count all these observations in the data? Do you think it'll count up to be 30 now? Obviously not. It's going to be lesser than 30, right? So this kind of data is known as an unbalanced data, wherein you have unequal number of observations for the time period across against each cross section unit, right? So for example, A has only 2 observations, whereas B has 3. So we have 1 missing, because of which this entire number is less than 30. So this was the first classification of panel data. And then we have another way that we classify panel data, which is called as short or long panel, or also sometimes called as micro or macro panels, right? Now, what do you understand by short and long? And this is something we should know for application of techniques, because there are different techniques for different kinds of panel data sets. So when we talk about short panel, that means the time period is smaller than the number of cross-section units. So easiest way to remember that I do is n cross t. I say n is greater than t is a short panel. Just the opposite, where n is less than t is going to be a long panel data set, right? Okay, generally what I observed in finance, what I see is a lot of people work only on short panels, whereas in certain economical research, I see that, since they deal in, at national level data points, wherein they take the cross-section unit as number of countries, and variables are taken for a long number of years, say 25 to 30 years past. So in that case, those sort of panels are long panels. So economic researchers at times, they deal with long panel data sets. All right. So moving ahead now, so far what we've understood is cross-section, time series, and how the amalgamation is known as panel data. Types of panel data, we have covered balanced, unbalanced, as well as short and long. So this we're supposed to remember for future slides, right? Okay, moving ahead, I'll talk about now where can we apply panel data, right? So far what I've observed is generally in statistical, financial and economical research, it is already being applied, right? Say, let's understand certain examples to see how we actually use this in these domains. So when you talk about statistical domain, say for example, if a researcher wants to know that, what is the best educational system, in a particular city, or say number of cities, sorry, for last 5 to 10 years. And then they take certain variables, say what was the graduation rates from last 5 years, what was the employment rates just after the graduation, for those students, what were their grades, every year, and so on and so forth. So this kind of a trend that they want to see is a statistical sort of a research wherein we use a panel data. Here cities are going to be the cross-section unit, and we are taking time dimension here as 5 years or 10 years down the line. Okay, moving on to the economical research, there are macroeconomical research domains as well as micro level research. So talking about macro level trends, so say for example, when you're dealing with currencies, right? So suppose a researcher wants to investigate the spending power of different currencies. Say I take 3 currencies, Indian rupee, euros, as well as say yen, right? Now, how are they performing as against the dollar? So I'll take up the data for past, say, 10, 15 years, and I'll see how have they been performing against the US dollar. So that kind of, investigation could be done using the panel data, wherein the currencies are my units and year dimension is, say, 10 years if I take that. Okay, moving ahead to a small scale economic analysis. So for example, I would like to see, if certain educational institutions are ranked higher, right, than certain others. So likewise, we have rankings, right, at national and international levels. So is it really true that the ones which are ranked on a higher scale are providing, their students are actually getting higher average salaries? So if you want to investigate that, you pick up the data of, say, past 15 to 20 years, look at their average salaries, and identify whether this is actually happening or not. So this is one example of small scale economic analysis being done. Then talking about finance domain, so there are multiple ways that we can use a panel data there. So one of them is, say, stocks, as I said. So for example, like the one example in the beginning that I gave you was stock price for just one stock, that was Microsoft, right? So for example, now what happens is you are looking at top 10 stocks as per some analyst who said that these are the top 10 stocks. Now you want to invest in either one or two, so you would like to look at how are these stocks performing, so that I am able to invest in the best of the two. So for that, you need to investigate the performance of all these 10 stocks for certain past number of years or days or quarters or things like that, right? So that's one area where we actually use panel data. Another area, say for example, is these days, rather it's been now not so new, but then we have CSR disclosures coming, right? So how CSR disclosures are impacting the financial performance of firms. So since the CSR mandate has come, from that year till now will be my time dimension. From there, I look at their disclosures. I also look at their financial performance and try to see the influence of the disclosure on financial performance. So this is how we actually use panel data in finance domain. All right, so this is something that is happening, right? What about other domains? So when I try to look into how other areas can also, apply panel data techniques in their domain. So talking about, say, HRM, human resource domain. So maybe, for rough examples that I could identify was, earlier we used to have different sort of HR practices, and now we have different sort of HR practices, because these practices also, they keep on evolving, right? So if there was an HR practice that was implemented, say, 5 years back, right, for, say, anything, maybe improving the employee performance or reducing the attrition rates. So how you can do is you can actually collect the data, last 5 years it was implemented, and try to look at how it has impacted the performance or attrition and so forth, whatever you try to investigate. Similarly, in marketing, since these days social media marketing is the new buzzword, and we have so many tools where you can actually market your products apart from the traditional marketing strategies. So you can actually look at, from the year you started the digital marketing tools, did that actually leave any impact on your sales? Were you able to increase your market share? So they're very small, rough examples. This is how in other domains also you can actually implement panel data techniques, right? So far now we have also understood what is panel data, its types, and where, in what all domains, and how can we actually apply panel data, or think of that, yes, we can actually apply panel data here for question. Next, now when the main question about panel data is for conducting the panel data analysis. Now here, this is the most important aspect of the session today. So now here I'll be a little more slow and I'll stress more here. So as I already told you previously, when we discussed about the types of panels, I said different types of panels are dealt with different techniques, right? They're estimated using different techniques. So now for now, we will restrict to, so if you were able to recall, we did short and long panels, wherein short panel was where n was greater than t. That means number of cross-section unit was greater than the time period. Say, for example, if I take the patient's example, which I took previously on a slide, I had 10 number of patients and only 3 months data. So my N were the 10 number of patients. My T was 3 months, where I took 3 months wait. So that was a short panel data where N was greater than T. So we'll restrict to short panels and their techniques for today's session. All right, so moving ahead, let's see, a panel is a combination of cross-section and time period, right? So now I have been using in my research, I've been using Stata as one of the softwares for, conducting my analysis for my thesis as well as research that I carry forward also. So I'm very friendly with Stata. So the kind of commands or conducting the estimation, I'll be relating this data alongside for those things, right? All right, so panel estimation is X cross T, right? X denotes the cross for cross section and T is the time period. So Stata is very smart, so what it did is it took XT as the identifier for panel data analysis. So the sort of commands that Stata has in its software for panel data analysis. So one of them is XT set, right? So what is XT set? So for example, now I have collected the data of those 10 patients for 3 months. I put it into Stata. I need to declare to Stata that yes, this data is a panel form of data. So when I write XT set, I mean to say to Stata that the setting of my data has to be XT. That means panel setting. So it manages it in a panel setting. Now, what is panel setting basically? So panel setting is, all right, so I'll share the panel setting in the next few slides. Okay. Or maybe right now, I'll just take a moment here. Okay, so I'll show you the panel settings here. Can you see the Excel file? Okay. Yeah. Right. So this was the raw data that I picked up for 10 patients and 3 months wait.
Yukti, your Excel file is not visible. We can see your PPT slide.
Okay, I think maybe we should wait for a moment.
I think, did you just share screen or did you share windows at the start?
Okay, I shared a window, I guess, yes.
You will have to share the screen.
Okay, sorry. Okay. Hold for a moment. Share screen, okay. So sorry for the interruption. Is the Excel visible now?
Yes.
Okay, perfect. So now we have this raw data, right? The raw data which I initially used, the patients and their weights. So now this data can be actually managed in a panel format. So we have two formats in which we keep our panel data, right? So one is the long format, the other is a wide format, if you could see here, right? So long format is a format wherein everything is stacked in columns, right? So if I look at my cross-section units, patients are also in a column. My time dimension, that is months, is also in column, right? So A for January, A for February, and A for March, and so on and so forth. This is a lengthy way of keeping the data. So this is known as a long format, right? Then there's another way that you can keep it. Keep one dimension on the in the rows and the other dimension in the columns, right? So if you see here, I have patients in the rows, and in the columns I have the time dimension, right? So this kind of a format is a wide format. Now to make it very clear, generally Stata prefers to take the long format. Generally we follow the long format, and it is how Stata actually sets this panel data in its data editor. So yes, so I'm here. Sorry. So we were here taking you back wherein I just explained how does XTset work. Then there's another basic command for panel data in Stata is xtreg. So xt is the panel data command, and reg means regression. This is a simple regression command that we use for panel data regression in Stata. Now, this was just the basic. Moving ahead now is the most important thing. Now we need to know, we know what is panel data, but what is the nature of panel data? What are certain issues that can that are there in the panel data that we can encounter while dealing or working with the panel data? Let us understand that. Okay, so for this, rather than reading what is there on the slide, I would like all of you to first go direct to the end of the slide where I have a model here. Can you see the model? So this model is a labor market example. So now, henceforth from here, I will be talking about a new example. I will leave the weight example from here, and we'll start on with another example to tell you what all issues or can you encounter when you are working with the panel data, or simply called as the nature of panel data, which almost every panel data has. Okay, so this labor market example is, so I have an equation wherein the model says log of wage, the dependent variable is the log of wage for firm I, sorry, for labor I, I'm sorry, I is the labor here, labor I in time period T is dependent on certain factors, right? This is a simple general multiple regression equation. Now what I see here is, now the labor wages are dependent on the education of that labor, the experience of that labor, certain other factors, and one important term here is EIT, which is the error term, right? So there are certain variables which are not measurable are sitting in this error term. Okay, so now this is a panel format of a model because we have I and T both on both the sides of the equation. This is how you identify whether this equation or this model belongs to a panel data set or not. You need to look at these subscripts, and when you see I and T together or X or T together, you see that it's a panel data. All right, now what does these three types of variation mean? Let's use a data of this equation and understand. All right, so the equation or the model that I explained previously, wherein I said the wages of a labor are dependent on certain factors, that's the data that you have. So what kind of a format is this, first of all? So if you look at, everything is stacked in column. This is my cross section. That means the person ID, the labor ID, labor number 13, labor number 17, labor number 18, and so on and so forth. So this is my cross section unit. Then I have a time dimension here. How many years? From 1980 to 87 for all these laborers. I have certain data points. I have log of wages, their experience over the years, their working hours, are they married or not, what is the education level, and so on and so forth. Now here, there is one important thing that you should understand is, one is this green color or the single color, right? So labor number 13, wages of the labor number 13 varies over the year, right? Over these number of years. That means within this cross-section unit, there is a variation. What do we call it as? Within variation, right? Then there's another thing that happens. If you look at across this cross-section unit, or you can say between these cross-section units, again, there is a variation, right? So this kind of a variation is known as between the cross-section unit, or you can simply say between variation, right? Adding the two is the total variation in my data. So this is what is written on this slide, wherein I mean to say, whenever you are dealing with a panel data, you generally have three types of variation in the data. One, which is going to be within just one unit, single cross-section unit, could be person, could be labor, could be car, whatever, right? Then you have across, or you can say between the units variation, and then adding up to we get the total variation in the panel data, right? So this is clear so far. So what we have understood post, we have understood nature of panel data, where we have three types of variations. Great. Now, when we move ahead, now why are we understanding about these variations? Why is there a need? Let's connect the dots now. Okay, so now we'll go more in depth into this data, right? So now one thing that we need to know is, if you look at this variable D81, what does that mean? It's a time dummy. So what is a dummy variable now? So a dummy variable is a variable. It's a categorical variable, first of all, wherein you want to have 2 or 3 categories, and you want to see the impact of other categories in relation to one, right? So for example, now here it's a time dummy. It's a time varying variable. That means if it is 1980, the value is 0. If it is 1981, the value is 1, and so on and so forth. So now this dummy places the value 1 for only 1981. Apart from 1981, the values are 0. But if we look at within one cross-section unit, it is varying and varying according to time. So this is a time variant variable. Okay, moving ahead, now we see another variable, that is female as well as education. Now what is female? Female again is a dummy variable, wherein the value is 1 if the labor is a woman, and 0 if that labor is a man. Now, but however, in contrast to D81, what do we observe here is this variable, no matter whatever year, labor number 13, if it is a man, if he's a man, he's a man. He will not become a woman in next year, right? So what does that mean? That means that this kind of a data point is time invariant. It doesn't vary with time, right? And it is observable, right? I can observe it, whether he's a female, if she's a female, or he's a male, and all. So these are time invariant observable variables. Similar is the case with education. So if labor number 13 had 14 years of education, it will not change after that, right? So that remains same. Similar is the case. So this itself, again, this just like female dummy variable, even education becomes a time invariant observable variable. Okay, so now so far what we have covered is three types of variation and time variant variables, which was this, and time invariant variables. Now there's more to dig deep here. Now you tell me, can there be, apart from these factors, can there be other factors which impact the labor wages? And that too, those factors which are not quantifiable, or we can say they are unobservable. I'll give you an example. Say, for example, the ability of that labor to perform that task, right? So, or maybe the personality type, the talent. Can you actually measure that using numbers? No, we cannot, right? So we say, and of course, ability can impact my wages, right? So therefore, I say that this is also a factor which should ideally impact the wages. However, it is unobservable. So now what has happened in my model? I am missing one important variable which can impact the dependent variable. So we can call it as unobservable factor, presence of unobservable factor, or we can also call it as omitted variables, right? We have omitted variables in the model. All right. So now, okay, so up till here, another thing related to ability is, one thing, it's unobservable. Then we assume it to be time invariant. So that means the ability doesn't vary with time. Even after 87, 88, also you take the ability, we assume remains same for that person, right? Another thing that is very important to note is, now this variable that you omitted because it was not observable, there is a chance that this variable can also be correlated with some other observable variable. Can you think of anything? So say for example, if I have higher education, I might be more capable to perform this task. And if I have a lower level of education, I'm little less capable to perform this task. So I say that ability is, there's a chance that ability is correlated with education or maybe experience also, right? So what we observed in this entire slide, so time variant variables exist in a panel data. There might be time invariant variables. Now these are observable, but some of them can be unobservable. And although they are unobservable, they can also be correlated with some observable variables, which we do have in the model, right? Now, what happens if this? So this is the nature of panel data set. More or less, whenever you're working with a panel data set, these sort of issues tend to arise, right? Now, what to do? Let's understand. So as we saw that ability is unobservable. So what we say is, where is it then in the model? It is there in the model itself. Where is it? It is in the error term, right? So if you remember previously, in our previous slide, we had log of age was a function of education, experience, all other factors. And the last, we had one term, which was EIT, if you're able to recall, right? But now here, we do not have EIT. What do we have? We have two other variables instead of EIT. One is AI and the other is UIT. Now, what are these? So these both are my error terms only. So combination of AI plus UIT is nothing other than EIT, which was there in the previous equation. Then what are these two? So this AI is that ability which was sitting. I said it sits in the error term just because it is unobservable. All these are observable variables. Where are unobservable variables? In the error term. So this AI is unobservable variable sitting in the error term. So the error term has two parts, right? So this EIT was a composite error term, which has now been broken down into a purely random error term and the ability, that is the individual specific, right? Every labor has its own ability. So individual specific time invariant component. So now so far what we identified is there could be unobservable factors. They are in the error term. What next? Okay, so now this model is again written in the same way as it was in the previous slide. Now, as I said that this ability now could be related with education. The higher the education, higher is my ability to perform that task. Lower my education, lower is the ability to perform. So they are correlated. They can be correlated. So now this develops two cases for me. Now in this particular model, there is a chance that this AI is correlated with it, but there could be other models that you're dealing wherein this unobservable variable might not be correlated with any of these explanatory variables. So with which we develop two cases. Case one is when this unobservable factor is correlated with other explanatory variable, the other it is not correlated with. Now how to do, what to do? with that now, both of the cases. So now, so far we know what is observable factor. How do we get to know? Now here, how did you get to know about this? So this was intuitive, but in general, when you're dealing with particular domain specific research, it will come out of theories, right? So some theory will tell you that there's a particular unobservable factor, but it has a correlation with other observed explanatory variables, right? So we say that it comes from theory. Now, if they are correlated with explanatory variable, yeah, that means this case where AI is correlated with education, this kind of problem in a panel data is a very important terminology. We call this problem as the problem of endogeneity. So what is endogeneity? When there is a correlation between error term and any of these explanatory variables, right? So here, since education and AI are correlated, education becomes an endogenous variable here, right? And in the model, we have the problem of endogeneity. So you must have seen a lot of panel data papers these days. They have this kind of a terminology called, to deal with endogeneity, we use this sort of a technique and so forth, right? So this is what endogeneity actually means. Now, if we ignore this endogeneity problem, what happens is our estimation is not going to be right? So therefore, we need to consider this endogeneity. How can you do that? So now, so I'm skipping on this slide. This is more examples of how an error term can be correlated to other explanatory. So maybe you can just go through this later after the presentation as a reference point. All right. So when I say when there is endogeneity in the model, that means these unobservable factors are correlated with the one of the at least one of the independent variables, that is endogeneity. And in order to deal with endogeneity in this kind of a model, we use a particular technique called as fixed effects estimation. First of all, why do we call it fixed effects altogether? Is because if you recall this equation here, AI, it doesn't have T as a subscript, right? It doesn't have T. That means it is only cross-section variant and it's fixed over time. It's constant over time, right? So therefore, the name of this technique is fixed effect, because the problem endogeneity arised because of a variable which is unobservable and it is time invariant, it's fixed. Okay, how does this technique actually solves the problem of endogeneity, or this problem of AI in the model? So it transforms the model. How? Using demeaning as a process. Now, what is demeaning? Demeaning means basically you subtract the means of all these variables from each of the variables. So log of wage minus expected value of wage, education minus expected value of education, and so forth. Now, please tell me, what is going to be the expected value of this? Since over the years, this is time invariant, that means fixed. So the expected value will be AI itself, and AI minus expected value of AI, which is same, it cancels itself, and this effect is ultimately eliminated. So this is how we control for unobserved heterogeneity or fixed effects in the model using the fixed effects estimation. Talking about the commands in Stata, we have xt set. You put the dependent variable, independent variables, comma fe. So this is the command for fixed effects. And you store the output using estimate store fe. All right. Now, do you think fe is a perfect model? There is no model or no technique that is perfect, right? So it also has some flaws. What is the most important flaw here? So just like it eliminated the impact of AI here, it also eliminates the impact of certain other variables. Let's go back to the model and see. Now this female and education were also time invariant, though they were observable, but they were time invariant. Just because they were time invariant, their expected values are going to be the same. So they also get eliminated from the model. So the main problem is it eliminates more variables which are time invariant. So say, for example, gender, race, and so forth. So now this is a big problem. So in order to solve this, however, if you really want to take this data, what you can do is you can use interaction terms. right? So say for example, working hours multiplied by female, working hours multiplied by education. This way you'll be at least able to retain this data and make use of it in the data, and then you're not outrightly reducing your data points, right? Next, one of the next techniques that is there in the panel data is random effects model. Now it is used for another kind of a situation. So the situation for fixed effect was presence of endogeneity. However, if there is no endogeneity, that means error is not correlated with my independent variable. In that case, we suggest to use random effects model. Why? Because we say that why are you eliminating this all information? Right? Let's have more data points. So you have a scope that you can safely use more information. So because this fixed effect was just concentrating on this kind of a variation. However, random effects takes into account this variation also. And we know that total variation is important. We should consider the maximum variation in the data for efficient or better output or outcomes. Great. So now we've understood FE as well as RE. If we understand, the command is absolutely same. It's just that instead of FE here, we use RE. Similar is the command for storing the random effect output. Last and foremost important thing for these techniques are, how will you get to know that you should apply FE or RE? So this is just one very small example, right? When you will actually work on data, or generally when we work on data, what happens is we have huge bunch of data, multiple explanatory variables for a long time period. How will you actually get, and there can be n number of explanatory variable. And if you talk about omitted variables, there can be n number of unobservable omitted variables which are there in the error term. So how will you decide whether, first of all, what are those unobservable variables? Are they actually correlated? Can you actually do it? It'll take a lot of time. And at the end of the day, I don't think, you'll be able to justify that when you're dealing with a very large data set, which we actually do in research. So then how are you going to go about it? So no problem. Sit back, relax. We have the softwares to do the task for you. Right? So we have Hausman test. Hausman test is a test which actually tells you whether your data is appropriate for fixed effect technique or random effect technique, right? So Hausman test has a null hypothesis which states that the preferred model is random. Alternate hypothesis say no, fixed effects is the preferred technique. And then it's a chi-square test statistic. And then if the p-value is less than 5%, you all know we reject the null hypothesis. That means FE is better. RE is better. So Hausman tells you whether to go with FE or RE based on your type of panel data. The last slide for the day is going to be now a transition from panel to what is called as dynamic panel data. So far, if I take you to my equation, this was my equation, right? My model where log of age was dependent on certain X factors and my error term. If you notice in the last slide where I'm talking about dynamics, there is a new variable that I've introduced in the model. And what is it? If you look at it clearly, it is the same thing as the dependent variable. The only change that we see is here it is IT, where here it is IT minus 1. That means dynamic panel data takes into account the lag value of the dependent variable. And by this, what I mean to say is a laborer's future wage will be dependent on what he or she was actually earning in their past years, right? So the past predicts the future. So those sort of models, when you have, this is known as dynamic. And why do we call it as dynamic? Because if you look at, you are actually looking at the change from one time period to another time period, actual dynamics taken into account, right? All right, so what is the implication the moment you take it? So the moment you take it, very importantly note, this ability was impacting my wage here, unobservable ability. Okay. And if you see, it is not variant across time. So that means no matter whatever be the t minus 1 here, this AI remains same. So this impacts this also, and this impacts this also. So there is endogeneity in the model, of course, for sure. And there's another thing which we call it as serial correlation. Serial correlation means there's a repeated pattern in the model now because of the presence of lagged values of the dependent variable. Now, this also leads to biased estimates, which we do not want. So therefore, there are other techniques to deal with these kinds of data sets. One of them, which is very popular these days, is generalized method of movements, which I actually used in my thesis also because I was dealing with a dynamic panel data set. Right? It was proposed by Arellano and Bond in 1991. So that's it from my side. I won't take much deep into dynamic panel because I think it's too much to grasp in an hour's time. So thank you so very much. And thank you for your attention. And I'm open for any questions as well as feedback from all of your sides. So I hope I think I took more time. So we have some questions.
Yeah, can I ask something?
Yes, yes.
Actually, no, I don't want to ask. I just want to say fantastic presentation. If for those who don't know about panel, I think it was a very good introduction. It's just that we have to say that for Arellano Bond, we have a separate command. It's xt-abond in Stata and xt-abond.
Yes, I did not. Absolutely. So I did not mention the command because I did not go into detail of dynamics because the time did not permit. So if you all would want, we would definitely can take it ahead in another session because I actually have worked on, GMM estimation because my thesis was entirely revolving around dynamic panel data. So if next time, maybe we could absolutely take that ahead. And thank you so much for the appreciation. So anybody else, any questions or any feedback, I would be happy to take that.
I think that Konstantinos is absolutely right that was extremely clear, and not being a very quantitative person, I could follow probably 90% of it, and that's a real achievement for your presentation. It was a very clear presentation and gave a very powerful case for using panel data. Is there any evidence that panel data is sort of getting into the mainstream use by governments, etc.? The dynamic panel data, I should say.
So, dynamic. So, in the economical research, I haven't observed so far. Maybe I should look into, but in finance particularly, we are actually using dynamic panel data for, things like, say, for example, when you decide about or you want to check your performance, right? Say CSR disclosures impacting the financial performance of a firm, right? So we say the performance of a firm, if you're measuring it with, say, profitability, right? So previous year profits definitely have an impact on next year's profits, right? If you talk about stock price, previous year's stock, past day's stock price definitely has an impact on the next day's stock price because that's the base, right? So likewise, and we talk about investments also these days. So your investment efficiency, we talk about in finance, that is also dependent on previous years, past data values of investment efficiency. So that's how it is being used these days quite. I would say, as you said, panel data is the hot topic in finance. What I observed, it has evolved from panel to dynamic panel now.
Interesting. Okay. Any other questions from the audience?
Can I say something?
Yes, please.
Yeah, I wanted to also say that the distinction between fixed effects and random effects is something that bothers people. So that's why it was a very good presentation. For some reason, also, it kind of keeps coming back. People kind of forget what it means. So that was very useful. And also endogeneity, because now I think if you want to publish, almost everybody, if you have panel data, everybody will say to you, you have some endogeneity issue. And
Absolutely. And that's why I would say, even GMM techniques, it is also actually it also controls for endogeneity in the model.
Yeah.
So it is a unique feature of panel data which exists.
Yeah. And the thing about having this autoregressive term, the previous years lagged the value of the dependent variable, it can actually be more than 1 year. It could be 2 or 3 years in a sense
absolutely.
that. Yeah.
Absolutely right, sir. Very right. You've got it, because it depends on the question that you're investigating, right? So, for example, there could be certain there might be a dependent variable which is affected by past 2-3 years value.
Exactly.
Right. So in that case, you need to take into account T-1, T-2, T-3, and depends on the kind of question that you're dealing with.
Yeah.
Hi, Nigel. Can I make an intervention here?
Yes, please. Yes. Yeah.
I agree with Konstantinos, everyone else, that the presentation was very clear. It's actually quite an encouragement for other researchers to venture in panel data techniques. I'll say two things. One of them is on a practical level, which is that one of the problems of the panel data, it's very difficult for researchers to collect it. You are usually working with secondary data that is collected by major organizations. To collect particularly the time level dimension is quite labor intensive. That's one of the problems that if I tell my students to venture, they will say, I can collect it once, but I don't think I'll be able to collect it more than once. That's one practical issue. The other one is you refer to the Hausman test, right?
Mm-hmm. Right.
The way you presented it, I feel that there is going to be a problem with type 1 error there. You will be increasing your type 1 error by rejecting the null hypothesis.
Okay, so talking about
particularly on the time level. Economic data tend to be very correlated.
Yes, absolutely.
But I mean, to distinguish significant correlation there, I think that you're going to blow your type 1 error there. But I don't know what you feel about it.
Yeah, I'll get back to you on those both the questions. So first is the data collection that you talked about, right? So when we were also doing our thesis, right? So the first and foremost thing that we used to, when we were deciding about our topics of research also, right? So my supervisor used to tell me, keep in mind, just try to look at the question for which the data is available, because these days we have a lot of data available, particularly in finance, we have a lot of data available. So I understand if a particular data is not available, that really creates a problem. However, I mean, if there is a very close proxy available, I mean, you can always, make use of that. And if I talk about the labor hours put in for data collection and cleaning, that is something, if you are into research, I think you cannot do away with, and you should be, I mean, you can make use of techniques and softwares. I mean, Excel also, there are a lot of functions that quickly lead to data cleaning and, all those sort of things for managing it in a particular format. Even R, if you learn, R as a software is so quick. You just put a command and the data is just, arranged in the manner that you actually want it. Right? So there are, even Stata has a lot of command these days. You just have raw data and it gets your data converted into a format that you actually want. So I think if you have the data available, putting in efforts for collection, I think should not be a task. And then arranging it in a format, the softwares are here to help you. It's just that you need to learn them for once, and that will help you a long way in your life, in research particularly. Moving on to the next question, sir, talking about Hausman, where you said that there are a lot of correlations amongst the variable in the economic data. So I think you are right on that. So what we normally do is, I believe you might know it also. So normally what we do is, so when we have our data, right, before we go ahead with our final estimation technique, we actually do a lot of checks on our data, right? So one of the most important checks is, as you might have seen in the papers also, we do have correlation matrix wherein we see the correlation among the independent variables. However, if there are certain variables which have a little higher degree of correlations, we then tend to do a VIF testing, that is variance inflation, inflation. VIF, I've just forgot the full form. Sorry for that.
Factor.
So VIF
Factor.
Yeah, factor. So VIF testing also we do normally, on which if you tend to check if the variables, the values that are coming are less than 10 or 5, then that should not create a problem in the model. So I think that is one way that you can actually check on the higher correlations in the model. So if VIF values are high, you tend to actually, if the VIF value is higher because of correlation between two variables, then maybe you can just drop one and take another proxy for the same, things like that. I hope I was able to answer your queries.
Yeah, thank you very much, Yukti.
Thank you, Yuti. Unless anybody else has got a burning question, I'm going to bring it to a halt there. Very, very interesting talk on a very, very topical subject. I'm sure now we've been sensitized to panel data and dynamic panel data. We'll see it more and more. Thank you ever so much for giving us this talk, and we're very grateful. Thank you very much indeed.
Thank you so very much for providing me this opportunity. I would love to connect with all of you, and maybe we could do some good research together in the long run.
Great. Okay. Thanks everybody. I'm going to say the session's over, but thank you very much to everybody in the audience for coming. That was really really useful. Thank you.
Thank you all the participants. Thank you everyone. Okay.
Hey guys.
Happy weekend everyone.